Hi, welcome back. So just before the break, we were dealing with 3D trigonometry problems where we needed to use compound angles and double angle formulae to solve the problems. Let's continue with our last problem for the day. In the diagram, we have RA equals to the height of the vertical tower. T and Q are 2 points in the same horizontal plane as the foot A of the tower. From the point T, the angle of elevation to the top of the tower is 60 degrees. RTQ is theta, ATR is 60, and TQR is 60, and they've given us that TQ is equal to K meters. The first question says, show that TR is equal to root 3K over root 3 cos theta plus sine of theta. There's a second question that asks us to calculate something about RA. They want us to find, they want us to find RA here. So the first question we're going to find TR, and the second question we're going to find RA in terms of K and theta as we have it here. But before we look at trying to answer our questions, let's go and analyze our diagram. So what they've given us is they've given us essentially information in two triangles. So the first triangle they've given us information in is they've given us this right angle triangle here, RAT, and RAT has a right angle here, and it has angle 60 degrees, this angle here being 60 degrees. Okay, and the second triangle they've given us is this inclined triangle here. I'm going to use a different color. So this triangle TQA. Okay, so in the blue triangle, we only have one bit of information, which means we cannot solve it. But in this inclined triangle, we've got a 60-degree angle. We've got this theta here, okay, and we have this side belonging to the inclined angle. So remember, they want us to find TR. Okay, so we're going to use this inclined triangle to find TR. Okay, let's look at it again. So because we're using the inclined angle to find TR, remember the inclined triangle looks like this. So we've got theta here at T, okay, and we've got 60 degrees at this point, okay, and we have that this is equal to K, and we're trying to find TR. Okay, so we're going to be using sine rule because we don't have enough information to use cos rule. But remember, to find sine rule, we will need to find this angle first. So let's begin there. Okay, so we're going to find that angle, and that angle is going to equal to, let me just erase my markings here. Okay, so remember, to find that angle R1, we're going to have to use those two angles. So it's going to be theta minus theta and alpha were the other two angles in that triangle. So we had theta and 60 degrees, theta and 60 degrees in that triangle. Okay, so in other words, we're looking for this angle here. So that angle is now going to equal to 120 minus theta. So again, let me draw the triangle up here. So we got this angle as 120 minus theta. That's our R, okay? And then we've got T and we've got Q. And Q is 60 degrees, and this one here was theta, and QT was K. So now we're going to apply our sine rule to that triangle. And remember, we said we're going to use sine rule. And how are we going to use sine rule? Let's remind ourselves. We said we're going to say, because we're looking for TR, we're going to say TR over the angle across it. So it's sine of Q, that angle, will equal to TQ. Here's our full pair over sine of R1. Now we're just going to go and put in our values for that. So we're going to get TR, and the angle across from TR is 60 degrees. Okay, and then TQ is K, and we already worked out R1 to be 120 minus theta. Okay. Now we're just going to do some rearranging. We're going to multiply throughout by sine of 60. So the sine of 60 goes into the numerator there. Let's continue on the next slide. Okay, so we had k times sine of 60. Now remember, we want to show TR is equal to this expression here on the left, on the right. So we've got to continue with that. So that means we've got to expand this. And how do we expand this? We're going to expand this using our compound angle formula. So when we expand that using our compound angle formula, sine of alpha minus beta becomes sine of 120 minus theta becomes sine 120 cos theta minus cos 120 times the sine of theta. Okay, all right. At this point, if you were asked to use a calculator, you could have just gone straight to the answer from this step here. From this step here, you could have started just finding sine of 60, sine of 120, and cos of 20 on a calculator. If the question didn't ask you that, then you would have had to convert it to a special angle. So I'm going to include this step, but if it says without a calculator, you do not need to use this step. But I'm going to show you this because a lot of questions do, if you are asked to use special angles, then you're going to have to use this. So you're going to have to first make sine of 20 converted by reducing it in the second quadrant to 180 minus 60, so it becomes sine of 60. Similarly, cos of 120 will become, because it's a second quadrant angle, remember cos of 120 becomes cos of 180 minus 60, so it just becomes cos of 60, and because it's second quadrant, it becomes negative, hence we have negative cos of 60. Right, so now we're going to remember when you're multiplying out also, just don't forget that when you're multiplying out, you need to multiply those two negatives and they'll give you a positive. And so we're going to end up with k times sine of 60 over this, and sine of 60, if you look at your diagram, is going to equal to opposite over hypotenuse. So it's going to be root 3 over 2. Now if you had a calculator, you could have just done it with the calculator if you were allowed to use the calculator. We're going to use this angles to do it, so we don't need a calculator. So sine of 60 is root 3 over 2. Again, root 3 over 2. And cos of 60, so it's going to be adjacent over hypotenuse, so it's going to be equal to a half. So either you used your calculator or you use special angles to get this far. Let's go write a neater version of it. Okay, so that's where we were in the previous slide. K times root 3 over 2, root 3 over 2 times cos of theta plus half of theta, sine of theta. Now this looks similar, but there's some things kind of wrong, but obviously it's because we have, we need to find a common denominator in here. And the common denominator is 2, so let's start off there. So if you find the common denominator, we're going to get root 3 cos of theta all over 2. So we just added the numerators. Okay, and then we got k root 3 over 2, and because we're dividing by this, we're going to invert and multiply. So remember, when we invert and multiply, we're going to swap these two around. So it's going to become times 2, because remember we swapped it around, so it's going to be 2 over the numerator and the denominator are going to move around, so times 2 over root 3 cos theta plus sine of theta. Okay, and remember, what did they ask us to prove? They wanted us to prove that tk is equal to root 3k over, this is the question, remember? So we're almost there. The only thing we've got to do is now cancel off that. And when we cancel that off, we're left with 3k in the numerator, which is what they wanted us to prove. And the denominator, we have root 3 cos theta over sine of theta. So basically, we've now proved exactly what they needed us to prove. Okay, the next part of the question asked us to show that RA is equal to 3k over 2 times root of 3 cos theta plus sine of theta. So we're going back to our right-angled triangle TRA, which means we're talking about this angle here, this triangle here. Okay, and remember, we need to find, we said we're going to use sine of RTA. So sine of 60 is equal to, sine of 60 is equal to opposite over hypotenuse. So it's equal to AR over RTA. T or TR. Okay, so RA will equal to TR times sine of theta. And remember that we found TR in the previous question, and we had TR is equal to this expression here. So we're just going to plonk in that whole expression for TR, which was root 3k over root 3 cos theta plus sine of theta times sine of 60. Now we're going to substitute for sine of 60 because we know from our special angle triangles, or if you were using a calculator, sine of 60 is root 3 over 2. So we're going to put that into the equation. And remember, we're multiplying those two numerators together. So root 3k times sine of 60 becomes root 3k times root 3 over 2. And when we're multiplying root 3 times root 3, we know that we must end up with just 3. Okay, so that means our expression can be simplified into 3k over 2. This 2 will go into the denominator, so 2 times root 3 cos theta plus sine of theta. Okay, that brings us to the end of this lesson on 3D trigonometry. Thank you for joining me. Bye.